All right, so we found the lovely histogram of the probability distribution, and now it's time for us to move on to computing the mean, the variance, the standard deviation. Now, this is a review really of stuff that we've already covered. We did this in section 3.3, believe it or not, but I'll do it again. One thing I want to do is I want to make this row just a little bit error. There we go. Okay, so the mean. Well, the mean, in order to find it, you're going to have to do x times p of x. Okay, now that would be equal to number of home runs times the probability. There we go. And you can fill that in down the column. And then now I need the sum of that particular column. I know I could have dragged the sum formula over from the right, but that's okay. And while I'm on the subject, I'm going to make this all that same bordering, so that makes it easier for me to follow. I'm just going to move my probability histogram out of here so I don't have to look at it. Hold on one sec. Okay. Now back in section 3.3, we went to the trouble of actually dividing this value 1.39 by this value 1. But here it doesn't make any difference, because whenever you divide 1.39 by 1, you're just going to get the 1.39 in the first place. So that's your mean right there. Oopsie. And again, I'm going rather quickly through this because that's what the Excel tutorials will do. We'll show you how to do all of this at greater depth and all of that. But I'm just kind of whipping through it. All right, now here, in order to find the mean and the standard deviation, we need x minus the mean. But the mean has to have dollar signs. And then you square it. And then you multiply it by the probability. It took me a second to think of it. Kind of long. That's okay. I'm going to give it borders. Okay, so here's what I want to do. Equals parentheses x minus that mean value. And I give that mean value dollar signs because I don't want it to change. And I square that and I times it by the probability. Enter. Then I'll fill that down the column. And then I want the sum, so I'm going to drag this over because that's a sum formula right there. Cool. So the sum is that. Now, again, we don't need to bother with the whole division thing because we know that this is actually the variance. The reason we're not bothering is because we would just be dividing it by 1 anyway. And dividing by 1 doesn't really give you anything spectacular. Now, as for the standard deviation is equal to the square root. So you want to type equals SQRT of that variance. And there we go. And just on a side note, these are actually population values. The reason being, just for the side, population variance, this is actually a sigma squared. And down here, this is actually a sigma. Okay. Now, why is that? Well, it's because it's a probability distribution. It's automatically considered to be a population. These Red Sox games are considered a population unto themselves. And since they have probabilities associated with them, those probabilities imply that you understand everything about the full population. So it's just a way of thinking about it. So this is population variance sigma squared. This is population standard deviation. Okay. So the mean is 1.39. The variance, hold on, let me go get that from Excel. There we go. So now, how do we interpret that? If we were to select a 2004 Red Sox game at random, we'd expect there to be 1.39 home runs, give or take 1.135 home runs. You always use the standard deviation for the interpretation, not the variance, because the variance is home runs squared, which doesn't really mean anything in our context. All right, that's the expectation is really important here, and that's what we're going to talk about in the next video. See you then.